Hello class, here are the instructions for the transformational geometry practice activity that we're doing today in class. So it says directions, graph the following coordinates and connect the points as you go. Perform the transformation on the graph paper provided. So you're provided two sheets of graph paper. One sheet looks like this, which is the one that we've been using in class. And the second one looks like this, which is just quadrant 1. Okay, so what we're going to do with this particular activity, let me move this back out a little bit, is you're going to first graph this original shape. This will be known as our pre-image. So you will graph that on the graph paper, that first sheet. Okay, then what you're going to do is perform a reflection over the y-axis. Well, as we've talked in class, there's a rule for that, an algebraic representation. And we know that we're going to do xy is going to turn into, and for a reflection over the y-axis, we know we're going to have negative x comma y. So we know our x and our y don't trade places, but if we reflect over the y-axis, our x value is going to turn negative. So what you're going to do is you're going to take each of these coordinates and perform that transformation. Take, for example, this first one is 11, 4. Well, it says the x value is going to turn negative, so that x is going to be, or that 11 is going to be a negative. Then you'll do the next one, 13, 5, and again, the 13 is going to turn negative. And you will do that with all of the coordinates, and then you will graph that, okay? Then you're going to take those coordinates, those same coordinates that you just did, the ones that you just reflected, and you're now going to rotate the reflected image 90 degrees counterclockwise. Okay, well, a 90-degree counterclockwise means that we're going to use the rule y over x, or yx, because our x and our y are going to rotate. And since I'm rotating counterclockwise, I'm going to turn over the y-axis, which means my y is going to turn negative. Okay, so that means I'm going to take the points that we just did in number 1, and I'm going to perform this transformation. So that means my x and my y in this first coordinate are going to trade places for negative 11. And my y value, which in this case was my 4, it's going to turn negative. Okay, so again, I'm going to take my x and my y. They're going to trade places. And my y value that I had is going to turn negative. So that basically tells you when we rotate this reflected image, it's going to rotate down into quadrant number 3. Okay, because both my coordinates are negative. Okay, so then we're going to take, for our third one, we're going to take this rotated image, and we're now going to translate the coordinate 17 to the right and 4 down. Okay, so the translation for that then would be, or the rule would be x plus 17 and y minus 4. So we're going to take each one of these previously recorded points, and we're going to translate them. So this first one, I'm going to take that negative 4, and I'm going to add 17 to it, which gives me 13. Then I'm going to take this negative 11, and I'm going to subtract 4. Okay, so you would end up with negative 15. And what you might want to do for this particular one is definitely use your calculator. Okay, so then I'm going to take my next point, and I've got a negative 5, so I'm going to add 17 to that, which gets me to 12. And then I'm going to subtract 4 from 13, which is going to get me negative 17. And you're going to do that all the way throughout. Okay, so that's what we're going to do there. Okay, then we got one more to go. Next, okay, now those first 3 are going to be what we use that first sheet of graph paper for. Okay, so basically what's going to happen is your original image is going to appear in quadrant 1. Okay, but whenever we reflect this over the y-axis, this original picture is going to move into quadrant 2. And then we're going to take the image that's here in quadrant 2, and it's going to then be rotated into quadrant 3. And then our image that is in quadrant 3, it's going to be translated 17 to the right and 4 down. Okay, which will then put it into this quadrant. So you should end up with an image in all 4 quadrants if you do it correctly. Now the last thing that we're going to do is we're now going to take that original image and we're going to dilate it using a scale factor of 2, which basically means we're going to take our x value here and we're going to multiply it by 2, and we're going to take our y value and we're going to multiply it by 2. So we take those original coordinates that we had right here, 11 and 14, and we're now going to multiply each of those by 2, which we know gives you 22 and 8. Right? Well, the next coordinate was 13 and 5. So our dilation then would be 26, 10. And you'll perform that for each one of those coordinates. Now for this particular one, you're going to use the second set of graph paper. Okay, you're going to use this graph paper, which is just quadrant 1. Okay, so what you're going to end up doing is you're going to graph your first image right here, and then you're going to graph your second one on top of that, which is going to be a dilated image, which means it's now going to get bigger. Okay, and that's what we're going to be looking for. That's what we're practicing on this particular assignment. Can you use the algebraic representation to create the new coordinates of our shape? And that's what I want you to do on this particular activity. So good luck. I think you'll find this quite an interesting activity.